Hello everyone and welcome back. I am Mr. Cobalt and excuse me. In this video I'm going to be covering how to do the abbreviated form of electron configurations. And so the abbreviated form is pretty much like the full form, except you're going to be replacing the core electrons with the the abbreviated form, or the noble gas configuration. So I'll go over a few examples, and hopefully it'll be clear after a few examples what the abbreviated form is. So let's start with a noble gas configuration. So if we pick any one, let's do neon. So we'll do neon. Neon has 10. So neon has an electric configuration with 10 electrons. It'll be 1s2, 2s2, 2p6, 3s2. Let's see. Oops, I went too far. Okay, so 10 electrons. So this is the electron configuration for neon. And so any element that comes after neon, at least in the third period, is going to have this as its core. So if I go on to the next one, which is sodium. Sodium has 11, right? Sodium has the same electron configuration, 1s2, 2s2, 2p6, except now it has one extra electron. So it's going to have the 3s1, right? And so we have sodium, and then if we continue from sodium, we got magnesium with 12, so we could write magnesium. So same thing, 1s2, 2s2, 2p6, 3s2. So there would be 12 electrons. And we could keep going, right? Let's just do a couple more. So we would have aluminum and silicon. So we would have aluminum, right? So we could just write aluminum with 13, so it's 1s2, oops, 2s2, 2p6, and then 3s2, and then 3p1 for aluminum. And then we have silicon, which has 14 electrons, so it would be 1s2, 2s2, 2p6, 3s2, and then we have 3p2, and then so on. So we're working our way. So this here is the end of period 2, and this begins period number 3. So we're going across the period and we're writing our electron configurations. And you'll notice that as we're writing our electron configurations for each of these, you'll notice that every single one of these has the noble gas neon, the configuration already there. So if we bracket that, we'll see that they all have this as the same, right? So here we got that one there, and we have this one here. So this would be your noble gas configuration. And again, notice that we have, these would be the core electrons, and these would be your valence electrons because they have the higher electron, the higher energy level, right? So you can see core versus valence electrons, core, valence. So a short way of writing this is that since they all have, after neon, the third period elements will all have this noble gas, neon's electron configuration, as part of the core. So we could just replace the electron configuration here with the symbol for neon, but you need to have the square brackets. So what you could do is you could rewrite this as, so instead of this whole thing, you could just do brackets with the symbol for neon, you need to have the square brackets, and then you have 3s1. So this would be the abbreviated shorthand version of the full complete electron configuration. So this would be the complete electron configuration, this would be the abbreviated shorthand version, the noble gas version. So again, this would be Ne. So replacing this with the Ne, and then you have 3s2. This would be abbreviated Ne in square brackets followed by 3s2, 3p1, and then this would be abbreviated again Ne in square brackets 3s2, 3p2, and then so on all the way to the next noble gas, which would be argon. And then after argon, right? So what's after argon? So argon has, let's see, 18 valence electrons. So let's write down argon, right? So argon would be 1s2, 2s2, 2p6, 3s2, 3p6. So this would be argon. This would be the noble gas configuration for argon. So because argon is noble gas. And then any element after argon in the fourth period. So if we go to the fourth period after argon, you have potassium. That has 19. So potassium, you could write out 1s2, 2s2, 2p6, 3s2, 3p6, and then you got 4s1. So this would be the complete full electron configuration for potassium, but then the shorthand would be that since this part is identical to the noble gas configuration right before it, right? So again, this is period 3, noble gas, and then after that you're going down to period 4. So all the elements in period 4 are going to have this noble gas core. So you can replace that with that noble gas. So with the previous noble gas, you can write down Ar in brackets and then write out the 4s1. So you can either write it as an abbreviated version, or you can write it as the complete full electron configuration version of it. You should be able to do this on the homework or the quiz, be able to give either one if it's asked for on quizzes and tests. Your professor or your teacher is going to ask you probably to do that. So make sure you know how to do either one. Okay, I hope this is helpful. Thanks for joining me. If you like this video, share this video. Hit the notification bell so you can be notified of any other videos I put out. Hit the subscription button so you can subscribe to the channel, and make a comment in the comment section. Let me know how you're how you think of the video. What do you think I should cover next? If you have any questions. And thank you for joining me, and I'll see you next time.